welcome to our 1-3 Solving Systems of Equations by Elimination. Go ahead and title the top of our notes and put your name and date in that top right hand corner. And as always, remember to pause if you need more time to write anything out. Goes right below our title. We always start with our learning targets, so write down these two learning targets. I am learning to determine solutions to systems by elimination. And I am learning to solve systems of equations by elimination. Now we are going to start off with a real quick vocabulary. What does elimination mean for our systems? For our elimination method, we're going to add the equations together to get an equation with only one variable. That's the keyword, one variable. So the key to it is to eliminate one of those variables. So that's why it gets its name elimination, because the way we get one variable by itself is to eliminate another one. Now we eliminate the variable, so eliminate one variable by. And here's where I'm going to do like a little bit of scratch work on this, how you have to write down. So if you think about it, we said we had to add them. So if we're going to add 2x plus something to make it eliminate or to get it to cancel out, we would have to add it to a negative 2x, because positive 2x plus a negative 2x cancels out and just leaves us with just 0. So we eliminate one variable by adding opposite coefficients. And I'm sorry, I didn't give myself enough room there. So adding opposite coefficients. So opposite means different signs, so one has to be positive and the other one has to be negative. And coefficients, if we remember, is your number in front of the variables, like 2 and negative 2. And there we go. So now, just jog our memories about solving systems algebraically. We can still get those 3 types of solutions that we got for our substitution method and elimination method. But where we're solving algebraically again, it will look more like our substitution one. So we know one of the first solutions we can get is one solution, in which we write the order pair xy. And like it was with substitution, we get like x equals 2, y equals negative 3, and the order pair will be positive 2, negative 3. So our x value, then our y. And we box, I undid that too fast, so 2, negative 3, and we box that guy in because that's your final answer. The next solution we get is no solution. And no solution, we get x. Sorry about that, I got a little ahead of myself and I got a little eraser happy. So our no solution, which is where we write our no solution symbol with a line, circle with a line through it, because that one we end up with like our 2x minus 2x equals 8 minus 6. Then 2x minus 2x is 0. 8 minus 6 is 2. We talked about this before. 0 does not equal 2. So that is not a true statement. So that whole thing's not true. So it's a no solution. And that's the only part we have to put for that one. And the last type we see is infinitely many solutions. So infinite solutions. And that one we get with our infinity symbol. Remember, for this one's a lot like the no solution, except it'll be 2x minus 2x equals 8 minus 8, because 2x minus 2x is 0, 8 minus 8 is 0. That is true, which means it's infinite solutions. Anything that makes one equation true will make both equations true, so it's infinite solutions. Now we scroll down this way, we'll look at how to solve systems by elimination. Okay, so for our first step for how to solve systems by elimination is that we're going to make opposite coefficients by multiplying one or both equations. There we go. So once we make those opposite coefficients, that's the keywords for that one, then we're going to add the equations together. If you did step 1 correctly, a variable should cancel out or be eliminated. So one of the variables is eliminated or canceled out. I like to say eliminated because that's the name of this method. Oh, it jumped on me and now it won't go back down, so it's just got to stay there. There we go. So add the equations together to make sure one variable is indeed eliminated. Alright, step 3. So if we eliminate one variable, that means we still have another one left. So solve for remaining variable. I know that sounds reminiscent to substitution, and this next part is going to be reminiscent as well in that step 4 we're going to substitute the value of the variable into an original equation. So one of the ones we were given. Alright, the last step. Solve for other variable. And right answer. Oh, not rights, but right answer. Remember, there's 3 different ways we can write our answer. We can do the order pair, no solution, or infinity symbol, depending on what type of solution we get. There we go. Okay, so example 1 today. So if you notice from our notes, we're still looking at solving systems by elimination. So we're still looking for those opposite coefficients. So remember, coefficients is that same number in front. Oh, the whole thing shifted on me. Let's see if I can fix it. There you go. Same number in front of the variable, and opposites means we need to have one be a positive and one be a negative. So now we're going to focus our variables again, take it one at a time. So for my x's, I have a positive 3x and a negative 9x. They are not the same number, so as far as that goes, they are not going to be our opposite coefficients. Now, look at our y's. Need to extend my highlighter there a little bit. I have a negative 3y and a negative 3y. So as far as it goes, they are the same number. They're both 3, but the problem is that they're both negative, and I need one of them to become a positive. So what we're going to have to do then is multiply this top equation to make him a positive 3y. Now here's the cool thing. You can multiply anything by a negative 1 to turn the sign to the other one. So for this one, we're going to go from a negative to a positive, so we multiply that top equation by a negative 1. So I'm going to draw my line under these two. That way I know what my original 2 problems were. My 3x minus 3y equals negative 30, and my negative 9x minus 3y equals negative 18 were the original 2 problems. Now we're going to multiply this whole top equation by negative 1. So negative 1 times 3x is going to be a negative 3x. Negative 1 times 3y is going to be a positive 3y. And now negative 1 times 30 is going to be positive 30. Now, this one right here is already a negative 3y, so he's the one we want to keep. So we just drop down this whole second equation. So it'll be negative 9x minus 3y equals negative 18. Now, before we do anything else, we have to go back over here and check for the opposite coefficients one more time. So, we're focused on our y's like we did last time. So we have y, and now I have a positive 3y, and I have a negative 3y. So that means they're opposite. One's positive, one's negative, and then they're the same number in front. They're both 3. So we're good. We can now add these two equations together. So plus sign, and we're just going to add the like terms. So negative 3x plus a negative 9x is a negative 12x. My 3y plus a negative 3y are eliminated. They cancel out. We drop down our equal sign. Can't forget that guy. Always drop him down. 30 plus a negative 18 is going to be a positive 12. Last step to solve for x is divide both sides by negative 12. Negative 12's cancel, and x equals 12 divided by negative 12 is negative 1. There we go. I now have my x value. Okay, once you have your x value, the next thing we have to do is solve for y. So I'm going to grab my first equation up here before I fixed it. So it's my 3x minus 3y equals negative 30. And this time I know x is going to be negative 1. So we're going to replace x with negative 1. So 3 times x is now going to be 3 times negative 1 minus 3y equals negative 30. 3 times negative 1 is negative 3 minus 3y equals negative 30. Now at this step, it's just a two-step equation. All these have the exact same steps. You probably saw that in the last video, in that we're going to transpose, then divide. So we're going to take our minus 3 over to the other side and make them a plus 3. So negative 3y equals negative 30 plus 3. So negative 3y equals negative 30 plus 3 is a negative 27. Now, transpose check, we're going to divide. So divide both sides by negative 3. To solve for y, negative 3's cancel, y equals negative 27 divided by negative 3 is a positive 9. Alright. Now that we have our x value is negative 1, we have our y value is 9, we write our answer as an ordered pair, x, y. So the x value is going to be our negative 1 over here. So negative 1 comes first. Our y is 9, 9. There we go, and we're all good. That's our ordered pair, negative 1, 9. Alright, now let's see example 2. So example 2. It says to use elimination to solve the systems of equations. So we have 5s plus 2t equals 6 and 9s plus 2t equals 22. So first step, make opposite coefficients. So here's where a lot of people say, like, well, how do I do that? It's always your choice. So there sometimes is one easier to work with than the other. So if you focus real quick on your s's, they're both positive. 5 and 9 don't have anything in common. So they're a little bit harder to work with. If you look at your t's, I have a plus 2t and a plus 2t. So they already have the same coefficient in front of them. The only thing that I would have to fix is this sign in front, that plus. Because to be opposite coefficients, they have to have different signs. So in order to make our 2t to become the opposite of a positive 2t, we are told we can multiply one equation. And now it's once again your choice what you multiply by, but I'm just going to say the opposite of positive 2t is a negative 2t, so I'm going to multiply that top equation by a negative 1. Now, make yourself a bar here when we do the first set of multiplication. That way we know everything above this bar is the original two equations. Everything below it is what we fix. And now, for this top equation, we're going to distribute this negative 1. So multiply everybody here by negative 1. So negative 1 times 5s is a negative 5s. Negative 1 times 2t is a negative 2t. Negative 1 times 6 is going to give me negative 6. Drop down your second equation as is, 9s plus 2t equals 22. And now we make sure we have opposite coefficients. So I have a positive 2t and a negative 2t. So we have opposite coefficients, so we're good to add them together. So plus. And now, once again, we're just combine our like terms and just add up and down like we do, like kind of grade school addition. We got negative 5s plus 9s is positive 4s. Our negative 2t plus 2t is eliminated, so cancels out. And then negative 6 plus 22 is a positive 16. To solve for s, we're going to divide both sides by 4. And now 16 divided by 4 is 4. So I have my s value. Next, we need to solve for t. So once again, it doesn't matter which one you grab. I'm just going to grab the first original one. So 5s plus 2t equals 6. Replace this s with 4. So I'm going to get 5 times 4 plus 2t equals 6. 5 times 4 is 20 plus 2t equals 6. Transpose my 20 and make him a minus 20. So we get 2t equals 6 minus 20. 6 minus 20 is 14. Last step, divide both sides by 2, and we have t equals 7. Very last part is always put these in alphabetical order since we don't have x and y, so we're going to put 4, and then our 7, and we're good to go. Alright, one last example for today will be example 3. We have a negative 9x plus 3y equals negative 6. And negative 2x plus 3y equals negative 6. Alright, so remember, the whole goal once again is opposite coefficients. Different signs in front, same number though. So coefficients, that number in front, different signs. So take it one variable at a time again. Oh, I'm so sorry about that. I clicked the wrong button. There we go. So, highlighter, and now we have a negative 9x and a negative 2x. So they're both negative, and 2 and 9 are definitely not the same number, so they're not opposite coefficients. We look over here, we have a positive 3y and a positive 3y. Now they are not opposites right now, but they do have the same number in front, so they do have the same coefficient. So we're going to have to make one of those a negative 3. Since we already have one being positive, we got to change one to a negative. So I always like to take my top equation. So I'm going to take my top equation here. We're going to multiply it by negative 1 to change my plus sign to a minus. So I'm going to draw my bar under it to show that those are my original two problems. And now it's a big distributive property again. Remember, we're going to distribute negative 1 to everybody inside that parenthesis. So negative 1 times negative 9 is a positive 9x. Negative 1 times 3y is a negative 3y. Equal sign drops down. Negative 1 times negative 6 is a positive 6. Now, my second equation's already a plus 3y. We want to keep him, so we just rewrite him. So negative 2x plus 3y equals negative 6. Alright, so once again, before we go any farther, we want to check and make sure we indeed do have opposite coefficients. So we were focused here on our y, so we look at our y's again. I have a negative 3y and a plus 3y, so they are indeed opposites because they have different signs. One's a minus, one's a plus. They're the same number in front, 3, 3, so we're good to add them together. So now we do 9x plus a negative 2x, and that gives us 7x. Negative 3y plus 3y is eliminated, equals 6 plus a negative 6 gives us 0. Now, last step to solve for x is to divide. Divide both sides by 7 to get rid of the 7. 7's cancel, and y equals 0 divided by 7 is still 0, so x equals 0. And that's okay. We can get 0 because if you think about it being a point on a coordinate plane, 0 is a point on a coordinate plane. Okay, and now that we know x is 0, we need to solve for our y. So I'm going to come up here and grab my first equation. negative 9x plus 3y equals negative 6. And now we know x is going to be 0, so negative 9 times x will now be negative 9 times 0 plus 3y equals 6. Sorry, negative 6. Now negative 9 times 0 is going to give us 0 plus 3y equals negative 6. But if you think about 0, it's not going to change anything. So anytime you get a 0, you can just kind of mark it out. We don't even need to show the 0. And now we're just left with our 3y equals negative 6. So to solve for y, we need to divide both sides by 3. 3's cancel, and y equals negative 6 divided by 3 is negative 2. Last little bit is to write our order pair, x, y. Our x value is all the way over here, and it's 0, so x is 0. 0 comes first. Y is negative 2, so negative 2 comes second. We're all good, and that finishes up with solving equations by elimination, in which we have to multiply one equation by negative 1. So in today's practice work, all of them is one of those where we'll have to multiply one equation by negative 1, so then we can add them together. Thank you so much.